ES6 map object is a built-in data structure that allows you to store key-value pairs where both the keys and the values can be of any data type, including objects and primitive types like strings, numbers, and symbols. Unlike objects in JavaScript, map provides a more convenient way to work with key-value pairs and offers several advantages. To create a map in ES6, we use the map constructor and pass an iterable containing key-value pairs as arguments. So first, we'll create a set of keys and values. Next, we'll declare our new map using the map constructor and pass our key value pairs that we just created. When we log this out, you can see we get exactly what we'd expect, right? All of our keys and values. What makes the map object so powerful, however, is its built-in helper methods. These methods allow us to perform various operations on our objects. Let's go through them. First up, we have set. Set, as its name suggests, allows us to set new values in our object. This method takes two parameters, the name of the property we want to add and the value being set. In this example, we create a new map and set two new values. Go ahead and run that. We can see we have two new values here, key 1, value 5, and key 2 of value 5. Next, we have get. The get method allows us to retrieve an item from the object based on a specific key. If nothing at that key exists, it just returns undefined. In this example, we have two items in our map with properties key 1 and key 2. However, when we try and access a key 20 property, which we know doesn't exist, we should see that it's undefined. So let's go ahead and log that. Key 1 value is value 1, key 2 value is value 2, and then that key 20 value is undefined. Next up, there's the has method. Has checks whether or not a specific key actually exists in the object. It returns a boolean of true if the key exists or false if it doesn't. In this example, it's almost identical to the previous example, but instead of accessing properties, we're checking for their existence. If we log this out, we can see that we get booleans now instead of values. So key 1 exists, does, true. Key 2 does exist as well, but key 3 doesn't exist. So instead of undefined, we get the boolean false. And then we also have a delete method, which, as you can probably guess, removes items from the map object. So if we look at an example for that, let's say we have a map with two items in it, and we set a new third item here. If we log this, see, we'll get exactly what we expect, a 3-item map where we now have a new third item. Now, however, if we run the delete method, right, so we'll delete the one we just added. If we re-log that out, we can see that that has now been removed from our map. Last but not least, we have the clear method, which is our nuclear option. Clear will remove all items from your map. So let's look at an example of that. Let's say we have these 3 items here, and we just want to clear them all out. If I go ahead and log that now, you'll see we just get a map of 0 items. Now that we know what we can do with maps, let's talk about some of the key characteristics of maps. First and foremost, maps are iterable. That's right, people, they're iterable. This means we can run for each or for of on them just like we would a traditional object or array. Example of that, we can see here I have a map with 3 items being set, running for each on them, spitting out the key and value for each iteration. We can see that works as we would expect. Next, let's talk about the dynamic sizing of maps. It's really easy to determine the exact size of your map object. The size property is always available and updated as you make changes to your map. So in this example, we have 3 items in our map, right? Set 1, 2, and 3. And then later in our code, some things happen, and then we remove 2 of those items. If we log those out, we can see the before value here is 3. However, the size property is automatically updated after we delete these 2 keys, and now the new size is 1. So this is a property that gets updated dynamically, automatically as you make changes to your map. It's really cool. Maps also have some of the most flexible key types you can ask for. Even objects themselves can be keys. It's awesome. Let's dig a little more into this last one, as I think it adds tremendous value to the object system in JavaScript. So for this example, let's say we have a large library of books and we need to be able to find these books based on some unique combination of data. Let's say we need to find these books based on the title and author. Well, we can catalog our books using exactly that information, using the title and the author. First, we'll create ourselves a new map. call this book map. Next, we'll define our new unique book key using an object that consists of a title and an author. So in this case, our book key, the thing we're going to be searching for is, give me the book where the title is The Great Gatsby and the author is F. Scott Fitzgerald. Now we'll use the set method, and for our key, we'll use our book key object, and for our value, we'll provide a genre, the year the book was written, and an arbitrary rating, right? Finally, we can use the get method to get our specific book based on the title and author object we created. So we just do bookmap.get and then pass in that that book key object. And if we were to log this information out, you can see we get all the details we'd expect, right? For the book, we're leveraging the book key object. So we're able to get that title, we add the word by there, and we're able to get the author, and then we can also get the information from the book info, right? So the book map itself, we can get the genre, the year, and the rating. And if we log out book map, we can actually see that the key here is that complicated book key object that we created. It's really, really cool stuff. In summary, guys, maps are an extremely powerful feature in ES6. And here's a few reasons why they've quickly become one of my favorites. First off, they help maintain order when the order of your keys is important. Second, they store arbitrary data types where sometimes you need the searchability of your object to be a little more robust. Lastly, they help you avoid prototype pollution since maps don't inherit properties from any prototype chains. Bottom line, developers, maps are the evolution of objects and you should be taking advantage of them wherever it makes sense.